Hello everyone, welcome to the course on architectural designs of ICs. So, this is the introductory video and myself Dr. Indranil Hatai. I am an assistant professor in the School of VLSI Technology, IIST Shivpur. So, today we will see that means why we need to know about these architectural designs of ICs and what are the phases it goes through whenever we are developing one ICs. That means ICs means integrated circuits. So, why do I need to need to learn this course, how it will help you to improvise or to improve your skills when you are designing or you are associated with designing any integrated circuit. So, the thing is that Gordon Moore, the co-founder of Intel, he predicted that initially in the earlier phase, he predicted that the number of transistor per chip would grow exponentially. That means, it would be double in each 18 months. So, we can actually in the present days, if we see the scenario, we can see that means in the technology there are exponentially improvement, like if we see that means in the automobile application. So, how it basically evolved from one generation to the another generation. The same things happen if you see that means the wireless communication. It has started with 1G, then now it is that means the era of 4G, and now it is that means it is trying to move on to the 5G. So, what are the changes or what are the need for that? That means the users need more data to be accessed. Okay. So, that is why every day basically peoples or the researchers are trying to that means increase the data rate by founding newer algorithm, then algorithm to its architecture, and which architecture is basically helping to make the hardware for that, so that the users can use it for their purpose. Okay. So, if we see these IC products, okay, so it has been that means everywhere you can find this integrated circuit, like these processors are used in CPU, DSP, controllers. Then if we use memory chips, that is RAM, ROM or electrically erasable PROMs, then programmable, what are these programmable and all those things we will come later to this lecture. Then programmable PLA, FPGA, and then embedded system. Embedded system is basically it is used in cars, factories, network cards. Then latest trends is this SystemonChip. So, this is basically the part of the VLSI. Okay. So, and in VLSI what we do basically, suppose we have one concept. Okay. So, that concept should be we have to make that concept into reality. Okay. That means that should be working, and that working phase that will be used by the user. So, how do I do that? Using by making the integrated circuits only, or making the hardware for that. Basically integrated circuit means we are building the hardware. So, that hardware building is basically passes through several phases. Okay. You can implement, there are different, that means implementation platforms where you can implement your hardware, and then what are the things you need to know about that implementation platform, that we will cover in this introductory lecture. That means, in this introductory lecture is all about, that means what is there or what are the phases which basically passes for one VLSI design, and then after this introduction we will see whenever we are passing through this particular VLSI design phases. So, at that time how these architectural designs of ICs that will help in each of these phases. in each of these phases means each of these phases it is that means that is the out of this course, that is that the whole phase will not be covered into this particular course, but how you can achieve the optimization in architectural design or this logic design, that means logic optimization phases, that will be covered in this particular course. Okay. So, why that means why I need to know, or what is the that means what is the intention for learning or to that means know about this architectural designs of ICs. Why? Because there is a stronger marketplaces. So, stronger marketplaces means what? Basically, if you see, that means nowadays every 3-4 months your cell phones are basically changing. Cell phones are changing means it is coming with newer features. That means the company who will come with, that means who will come with a product which has unique feature, so he will get the maximum, that means market capture. In other terms, if I say, he can capture most of the money from the market. Okay. So, the company's perspective is that means if you know that, and that means the faster you develop the chip, you release to the market, you get the market and make the money. Okay. So, that is the that means primary intention of the companies. Okay. So, this basically this needs basically put the pressures on the engineers or the researchers who are building the ICs. Okay. And whenever we are so, that is why you can see that this basically decreasing the design window. So, design window means for making one chip from concept to the reality, it takes some time. So, whether that should be 3 months, 4 months, 6 months, 1 year, 2 year. So, there should be one fixed time. So, that time is basically reducing day by day as the market needs becoming day by day, that is basically becoming more and more greedy. So, that basically decreasing the design window. Okay. And the second point is that is less tolerance for design revision. So, less tolerance for design revision means, so whenever you are building one ICs, at that time it has so much of it associated with so much of cost. So, cost in terms of that means the researcher or the workers who are basically developing the ICs, then the fabrication cost, along with that so many other costs are there which are associated with one particular IC whenever I am making. So, that means if I design one faulty IC, so at that time all the money or all the effort which are associated for building that particular IC, that all are in vain. Okay. So, that is why whenever you are designing one IC, particular IC, so at that time you must be more cautious about that it is fault free. That means whatever specification or whatever, that means whatever design you want to do, the circuit which you have realized, that also working, or that performance of the particular IC, that are same where from you have started. Okay. So, that means in each of the phase you have to do the revision. That means in each of the phase you have to that check whether that design is working fine or not. So, when the design window or the design time that is reduced, so at that time you are not getting that much of time for doing the revisions. Okay. So, that is why this stronger pressure market, it is not only decreasing the design window, it also creates the problem of reducing the time for design revision. Okay. So, that means the fault checking, that is not that much rigorous, so that you must have, as a engineer or as a researcher or as a designer, you must be more cautious whenever you are designing the ICs. So, that means, and how you will be more cautious if you know what you have to achieve and if you know how you have to achieve. So, at that time, that means if you are more proficient to do that, so obviously you can cope up with this decreasing the design window, as well as though the design revisions are time is less. So, we can cope up with both of this. Okay. So, exponentially as stronger market pressure, basically that increases the exponentially more complex, greater design risk, greater variety and smaller design window, as I have already discussed this. So, VLSI design style. So, VLSI design styles are basically means there are different styles where how you can implement your circuit. So, one of those is full custom design, then semi-custom design or this application specific integrated circuit using programmable logic, that is PLD or this FPGA, and then another thing is that is system on a chip. So, these are the VLSI design styles, that means or the implementation styles how you can build your ICs. So, I will just brief about all this, that means what are there in that means what does this full custom or this application specific integrated circuit ASIC or FPGA means. So, I will just describe I will briefly describe each of those. So, full custom custom design, each circuit element carefully handcrafted. So, handcrafted means here every element or each of the circuit element you have to do it by yourself. Okay. So, no, that means automation tool will help you to build your circuit. Okay. So, we will see how that means this is differs or what does it means this each circuit element carefully it is handcrafted, what does it means, we will see later. Whenever we will see the examples, at that time it will be much more clearer to you. So, it cost with a huge design effort, then high design and non-recurring engineering cost, high performance and typically used for high volume application. So, whenever I am doing each circuit element or each of these is handcrafted, at that time it needs lot of effort. So, why a lot of efforts? So, that means I have to be more careful or I have to be more cautious whenever I am designing this particular circuit using these styles. So, at that time that is why it requires huge design effort, it requires huge cost and the time also for designing this. If I follow this particular full custom design, so at that time it requires more time also. So, but in terms of what? In terms of whenever you are doing this yourself, that means you are making you are following this full custom design. So, at that time it gives you the highest possible performance in any of these styles. Okay. And that is why it is basically used for high volume application, so that the cost per unit that becomes lesser. Otherwise, if you for small volume application, the cost, this NRE cost or this design cost that are so much high, that means per volume cost at that time it will be much more on the higher side. So, that is why if you require one high volume application, at that time the cost per unit that will be lesser, as it gives you the highest possible performance among all of this design style. So, then this application specific integrated circuit, or this also you can call as semi-custom design. So, here semi-custom design means in the first point you can see this constraint design using pre-designed component. That means, here in full custom what we have seen that each of the element, that means it starts with as you might be knowing this, in VLSI design you have to there are several that means steps, they are like you can start from circuit level, that means you transistor level, then you can start from gate level, or above that you have, that means each of the component, basic components like adder, multiplier, this then divider, something like this. So, you can start from transistor level, you can start from gate level, or you can start from the upper level, which is this basic components. So, in semi-custom in full custom, or you have to start with transistor level. So, in application specific or the semi-custom design, you have to start from the gate level. That means, some of the pre-designed component or these gates or are already pre-designed, and you can use those, that means whenever you are designing one particular circuit. So, at that time those gates will automatically be you can use in your design. Okay. So, that is why it is basically known as semi-custom, not full custom. So, semi-custom. So, here CAD tools means this this design automation tool. So, CAD tools greatly reduce the design effort, and this low that means gives you this low design cost, high this non recurring cost, and the per unit cost is also low. But then whenever actually there is that is the nature's law, that whenever you are gaining something at the time you have to lose somewhere. So, as I am that means gaining, and here that another advantage is that as I am starting from one level higher than the full custom design. So, at that time the time for requiring the time which is required to design your particular circuit, that becoming lesser than the in comparison with full custom design. So, but I am achieving this low cost per unit, and this time to market is also reduced. Okay. So, then where I am losing? I am gaining these things, but I have to lose somewhere. Where I am losing? The performance. In performance wise, it is lower than the full custom design. Okay. So, this is the semi-custom design style. Then another design style is that this programmable logic. So, it is known as that pre-manufactured component with programmable interconnect, and CAD tools greatly reduce design effort. Here also low design cost, low non-recurring engineering cost, and then lower performance also. That means as I said, and one point is missing, that is advantage is that it requires much lower time than, that means the design time is much more lower than the full custom and the semi custom. Okay. So, here you see this non-recurring engineering costs that are high, and here this low this programmable logic, it requires low non-recurring engineering cost. Why so? Because in semi-custom design or full custom design, you have to, whenever you have that means you have build your chip, that means you made the circuit, then you made the layout, and then this layout information that you send to the foundry for fabricating it. So, that means it requires some of the cost, okay, for particular fabrication also. Okay. So, that is why this full custom or semi custom, that requires higher cost. But here in programmable logic, you have one pre-built chip that are basically comes with this pre-manufactured component with programmable interconnects. So, the difference is that in application specific or this semi custom or full custom, whenever the design is fixed, you send it to the foundry, you cannot change. Once it fabricated, it got fabricated, you cannot change its functionality. But in programmable logic, what you can do, you have the option to reconfigure it. That means whenever you have, that means after the manufacture you found that okay, that means somewhere you made the mistake or the design is somewhere it is faulty. So, you have the scope to revise it, but in case of semi custom and full custom, you do not have the option or you do not have the scope to revise it. Okay. So, that is why basically this programmable logic in the initial design phase, that is a better choice. That means to validate your algorithm, to validate your architecture, you use programmable logic. So, once everything is fixed, then you can go for the full custom or semi custom design styles. But what is that means where I am losing here in this particular that means I am gaining in time to market, and then cost wise also I am gaining, but here what I am losing, it gives you lower performance than this full custom as well as semi custom. Okay. So, then this system on chip. So, system on chip, what is the idea behind this system on chip? Combine several large blocks. So, nowadays if you see, that means everywhere, like if you see one air conditioner, if you see one refrigerator, if you see one washing machine, if you see dishwasher machine, if you see cell phone. So, everywhere there is one that means microcontroller, and there is some other controller which is basically used for different application or different features. Okay. So, that means more the number of features in particular products, more the number of controller you need in that particular system. So, if you see one that means cell phone, nowadays one cell phone, if you see, it has camera, hi-fi, that means one very good camera senses. It has this, that means Wi-Fi connections with high speed. It has to support 4G connection. So, that means several blocks you have to use for different purpose. You can see, you can access the internet, you can see the TV, everything you can do in cell phone. So, that means you need several things or several components as you are providing more number of features to the users. So, more number of features you provide to the users, more the popular that particular product is in the market. So, that means in the company's perspective you are making more money. So, as a designer, whenever you are designing, at that time your company is making the money. So, company is happy, means you are also happy. So, in system on chip, what is the idea behind this system on chip is that combines several large blocks. So, as the day by day this time to market that are being reduced. So, instead of, that means starting from the scratch to build the whole system, it requires lots of time. So, instead of doing that, block wise if I see, that means in particular system, if I need 10 blocks, okay, and each of the blocks, let us consider each of the blocks consumes 1000 transistor. So, if I follow this semi custom or full custom design, so at that time I have to, that means 10 into that means 1000. So, 10,000 transistors I have to deal with whenever I am following this full custom or semi custom or these two. So, in system on chip, instead of that, what I am doing, I am just picking one, that means this 10 blocks are there. I will only consider about these 10 blocks. What are there inside these 10 blocks, I will not consider. Okay. So, here the thing is that you see this pre-designed custom cores, that means this microcontrollers or the controllers for the camera or the controllers for the, that means the hardware for the this Wi-Fi or the hardware for the 4G VoLTE support. So, all these I have to just collect this from other third party vendors, or I will just build this particular block previously, I will just use it in my system. So, that means I have to provide one unique features. So, if one third party vendor is basically developing that particular controller, so I will buy it and I will use it into my system. Okay. So, that is the main idea behind this system on chip. That means, this core wise, or that means one level higher from this semi-custom design, which is this that get level design. So, here I am component level design. So, I will collect those components and I will use into my system to reduce the time to market. So, here the another thing is that ASIC logic for special purpose hardware, programmable logic, analog. The issues are that is dealt with this system on chip is that you need to keep the design cost very low and verifying the correctness of the design. So, verifying the correctness of the design means, as you are in the higher level, that means you do not know about the, you are using the course means you are using the intellectual properties somewhere, that means a controller which has been designed by some other person. So, at that time this how you can check as the design has been made by some other that means researcher or other people. So, at that time whenever you are integrating those IPs different from different vendors. So, at that time verifying the correctness of the design, that becomes very much challengeable whenever you are using or you are following this system on chip design style. Okay. So, for today for today's lecture, this is it, and next day again we will see some interesting things on this particular course. Thank you.